Vocab basics. This is coming from chapter 1 of our e-text, sections 1, 2, and 3. It's pulling from all 3 of them. So this is an overview of statistics in our first section. So there's a lot of definitions and key terms that you should know, but also pay attention as we're going through this to examples of the situations. Oftentimes the problems are going to be set up where it's a situation and then you have to identify the term that's being highlighted. So starting from the beginning, what is data? Oftentimes when we think of data, we think of like an Excel sheet with long lists of numbers, but actually it's going to be information coming from observations, counts, measurements, or responses. So it's going to contain things that are numbers and sometimes not numbers. So here's an example. It says, according to a survey, more than 7 in 10 Americans say a nursing career is a prestigious occupation. Here's another one. Social media consumes kids today as well, as more scored their first social media accounts at an average age of 11.4 years old. Both of these contain data in it, and a lot of times we see these little quick facts and information, but we don't think about how much time and energy went into find those numbers, those averages. A lot of data went into that and a lot of research and time. So what is statistics? What are we here doing? Statistics is 4 things. It's collecting the information, it's organizing it and putting it all together, analyzing, which is where all the math is happening, and then interpreting the data to make the decisions. So what kind of conclusions you get from it. This course specifically is going to focus more of the analyzing, the math of it, and then the interpreting, what conclusions we can make. So our data sets are going to be divided into 2 groups. There's a population, which is a collection of all outcomes, responses, measurements, counts that are of interest. And then there's also a sample, which is just a subset or a part of the population. So the big difference between these two is population is all and a sample is part. So these are the keywords right there. Other times with sample, you might hear it say some, or it'll mention a specific number, but you know that there's actually more than that. With population, it'll say things like all, every, or it'll count every single thing that is in the group. So here's an example. It says, in a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population in the sample, describe the sample data set. So this one intentionally sometimes tries to throw you off based on the fact that they're giving you 2 different numbers. Most people kind of jump to, well, that must be the population in the sample. But population means all. So when we're looking at this situation, we're looking at all employees in the US. So there doesn't have to be a specific number for it. We just want, what is the big picture? If we could get everybody, who would that be? And it would be every employee in the United States, which is very hard to get. So that's why we are often using a sample when we're doing our data sets. And again, that's just some of all of the employees in the United States. And in this case, it's 834 of them. Those were the ones that we actually accomplished. We went out and we surveyed. Now, the last thing it's asking for is describe the sample data set. That's where that 517 came in. So out of that 834, 517 of them said yes, and then we can figure out how many of them said no. If we know our total is 834, we could subtract 517 and we get 317. So that's the sample data set. That's kind of what we got from this. How many said yes? How many said no? So the next term we have to look at is parameter and statistic. A parameter is the numerical description of the population. So that would be something like the average age of all people in the United States. Parameter because we're talking about a population. And again, notice the P's are underlined here. Parameter goes with population. Statistic is the numerical description of a sample characteristic. So sample and statistic go together. It's the average age of people from a sample of 3 states. So not all were taken into account. So here's an example. Decide whether each number describes a population parameter or a sample statistic. A survey of several hundred collegiate student athletes in the United States found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. So you have to look at, is this a population or is this a statistic? I'm sorry, population or a sample. So if we go back to the beginning, we're talking to several hundred collegiate student athletes. Is that all of them? If it was, we would have said something to the effect of we talked to every or the entire collection of them all. But the fact that we mentioned the fact that there's only several hundred we got to, that's going to mean that this is going to be a sample. And because it's a sample, then we are talking about a statistic here. So the statistic is the 50 hours per week. Example 2. The freshman class at a university has an average SAT math score of 514. So again, you start by asking yourself, is it a population or a sample? This time we're talking to the freshman class. This one's kind of tricky sometimes because it doesn't say all, it doesn't say the entire or every, but the word the in this case is implying we're talking to all of them, the freshman class, everybody in there. So all of them means that this is going to be a population, which means the number that they're talking about is our parameter. And our parameter is that number, that average of 514. So here's a third one. Example 3, in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Ask yourself, population or sample? Since we're only talking to several hundred of them, that's going to be a sample, which means the number they're giving us is called a statistic, and that is that 34%. So we have different branches of statistics. We've got descriptive statistics, which involves the organizing, the summarizing, and displaying of data. So that's typically what you think of when you're looking at percentages, tables, charts, averages, things that are like quickly summarized into a single number or a range of numbers. The other branch is inferential statistics, which involves taking our sample data to make bigger conclusions about the population. So we couldn't talk to every employee in the United States, but if we talk to enough of them and we get good results out of it, good results meaning we've gone through the checklist to make sure it's statistically sound, then we can make blanket statements about the whole, even though we didn't talk to everybody. So there are two different branches here, descriptive and inferential, but they're not unique from each other. Oftentimes, you are doing the descriptive statistics first, and then you're doing inferential. So descriptive is giving you those results. Inferential is then what you kind of do with those results. So example 1 here says, for each study, identify the population in the sample, then determine which part of the study represents the descriptive branch of statistics, what conclusions might be drawn from the study using inferential statistics. So number 1 says a study of 2,560 U.S. adults found that adults not using the internet, 23% are from households earning less than $30,000 annually, as shown in the figure. So the first thing they are asking for is the population and the sample. So the who of ideally who we would want to talk to is all U.S. adults. So population is all US adults. But who we actually got is our sample. So our sample is the 2,560 US adults. So then when it asks about the descriptive branch, descriptive is the quick facts, the things that have been summarized. So for that, it is the 23%. Descriptive is oftentimes percents, averages. It is also the chart, the whole thing. This whole thing could be called descriptive because it's summarizing all of our data together. And the last piece of this problem, it says what conclusions might be drawn from the study using inferential statistics. So we're going to read it again one more time. It says a study of 2,560 US adults found that of adults not using the internet, 23% are from households earning less than $30,000 annually. So a conclusion you could make is that they cannot afford internet. If they're making less than $30,000 and they're not using the internet, perhaps they can't afford to have the internet at home. That would be the inferential piece. It's kind of like your conclusion sentence. So we're going to do another one just like that, number 2 here. It says a study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. So the population, think of them as the goal. Like if we could get all of them, who would all of them be? So in this case, all of them is the Wall Street analysts. And the sample is how many we actually got. So in this case, we got 300 of them. 300 Wall Street analysts. So which part of this is our descriptive? Again, that's that number piece, the summary of all of our information. It's the 44%. This is our descriptive piece. It's what we've summarized from what we got in our survey. And then for the last bit, what conclusions might be drawn from the study using inferential statistics? It doesn't look good, but it looks like only half of the time Wall Street analysts are getting it right. 44% does not look good. So your inferential statistics statement could be something like, half the time Wall Street analysts don't get it right.